absolute legends. In a weak acid and strong base titration, 3 points of the titration curve we will speak directly to. This is about point 1. Point 1 in a titration experiment is when you have your acid in the beaker and there is 0 base added to the reaction. So times 0, very much times 0. We will use a rice table to solve for the pH at this point. This is a formula of a generic acid doing its job, specifically a weak acid, so I'll have a double-headed arrow there. This is our generic capital K expression. Now we use this capital K expression here because it highlights the concentration of H+, which we need to do pH calculations. A rice table will tell us what this concentration is at equilibrium at the end of the reaction. Our initial molarities is what you know from the experiment because you set it up. So for example, for this equation, let's just make this 0.1 molarity initial concentration. These concentrations are 0 and 0 molarity. In our rice table, things are going to change in a logic reasonable manner. This is going to go down, these are going to go up, and these are going to go up. It's going to go down with respect to the balanced chemical reaction. So these 1s came from the balanced chemical reactions. If there were 2s and 3s up here, that's what I have down here. And it's still going to be some amount, X. In this slot of our equilibrium rice table, this is effectively what we get. 0.1 is going to go down a bit. 0 is going to go up an amount of X, so 0 plus X, 0 plus X. These values and unknowns correspond directly. They are the molarities of these things in the capital K expression. This is crucial to helping us solve for pH. Our X although these X's are identical, and they are, I do want to make very clear that, like, for example, both of these X's represent products, and let's say this one represents the H+, and this one represents the A-, but we know that they're the same value, they're both X. We know this value will go down a little bit of X, but because we know this is a weak acid, this is going to go down a very little amount. It's going to go down an amount so small that we're going to consider it 0 and negligible right now. This equation can very much be simplified. X squared equals 0.1 molarity equals K. If you know what the weak acid is, then you know the K value, and you plug it in, and you can solve for X, which is the concentration of H+, to take that to negative log. Because that is how you calculate pH, the negative log of the H+ molarity. So if you know K, you solve for X. In the lab that we do in this course, where we have an unknown acid, we will measure the pH, and we can plug that in for X to calculate for K. When you have a weak acid, and there are 0 moles of base present, you could be asked 2 kinds of questions. One question is, what is the pH? Run a rice table. Solve for X, plug it into negative log. Second type of question it could be asked for is you know the pH at this time, but you don't know the acid. So if you know the pH, you flippity-flop math magic, solve for X. You can plug that in here for X and calculate K, because now you have a single unknown variable. I hope this helps. Thank you.